You are looking at a Hubble image that demonstrates the fact that the universe is a vast stage for grand illusions. Albert Einstein realized this a century ago as he formulated his law of general relativity. Gravity, he said, wrapped space like stretching and twisting a rubber sheet. The consequences of that will make images of distant objects magnified, brightened and distorted into funhouse mirror views. This is because their light would be bent as it travels across the invisible tapestry of space and occasionally passes through gravitational potholes formed by massive objects that got in the way of light path to Earth. However, Einstein knew that seeing such illusions would require much more powerful future telescopes. Hubble was used to take a look at one of the most stunning magnifications of a so-called Einstein ring, a donut-like loop of light that is as eerie as it's striking. The object seen here is catalogued as Calculus 022058s. It is located in the southern hemisphere constellation of Fornax. The image was nicknamed the Molten ring. The lensing effect caused by the gravity of an intervening foreground object creates multiple images of the content of the more distant galaxy that are magnified and smeared into an arc. The galaxy is so far away that we see it as it looked over 9 billion years ago, when the universe was less than half its present age. This was a time when the universe was going through a baby boom, forming thousands of stars at a prolific rate. The magnified images of the galaxy gives astronomers a close-up glimpse into the distant past. Hubble Space Telescope's glamour shots of the universe are so revealing that they nearly always have a discovery behind them, not an exception in this case. In this particular snapshot, a breaking discovery of a deep space optical phenomenon dubbed an Einstein ring. This photo was released on December 2020 as an example of one of the largest, nearly complete Einstein rings ever seen. In this image, a remote galaxy is greatly magnified and distorted by the effects of gravitationally wrapped space. After its public release, the astronomers used a picture to determine the galaxy's distance of 9.4 billion light-years. This places the galaxy at the peak epoch of star formation in cosmic evolution. The extremely high rate of star formation in the brightest and the very dusty early galaxies saw stars being born at a rate 1,000 times faster than occur in our own galaxy. The object's unusual partial ring-like appearance can be explained by a phenomenon called gravitational lensing, which causes light shining from a faraway galaxy to be wrapped by the gravity of an object between its source and the observer. This effect was first theorized by Albert Einstein in 1912 and later worked into his theory of general relativity. In this case, the galaxy's light has also been magnified by a factor of 20. This magnification, boosted by Mother Nature, effectively made Hubble's observing capabilities equivalent to that of a 48-meter aperture telescope. The lensing effects also create multiple images around the curved arc of the single background magnifying galaxy. In order to derive the physical properties of the galaxy, astronomers had to precisely model the effects of the lensing on the galaxy's image. Such a model could only be obtained with the Hubble imaging. In particular, Hubble helped us to identify the 4 duplicated images and the stellar clumps of the lensed galaxy. The initial Hubble observation was first conducted by Saurabh Jha of Reuters, the State University of New Jersey. His team's science goal was to use Hubble's sharp images to reveal detailed complex structure in the ring arcs. Well, black holes are too far to visit, but Mars is not. How can we colonize Mars? Watch this video to know.